Alrighty, let's take a look at this next example. So we're given vectors u, v, and w. And the first thing we're asked to do is graph 2v. So what that literally means is vector v plus vector v, or just like with any variable, right? V plus v would be 2v, or you could think of it as 2 times vector v. But I want to start off just going vector v plus vector v. So we'll start in standard position, and we will go over 3 and down 3. Over 3, down 3. All right, so that'll be our terminal point in standard position, and our initial point will be at 0, 0. So there's one v. So now if I'm going to add another v onto that, I'm literally going to start where I left off, and that is vector v plus vector v. So now if I'm thinking about vector 2v, this is a whole different vector that has its own components, which we're going to write down here. What are the components of 2v? So 2v is going to start at the initial point of this v, and it's going to end at the terminal point of this v. So it's going to start here. Let me get this. It's going to start here, and it's going to end here. And it's going to look like I'm writing right over the top of it, but I'll try to write a little bit next to it. All right, so this is vector 2v. So it has components of, so these are the components, like how far in the x direction did we go? How far in the y direction did we go? Well, we went 6 units in the x direction and -6 units in the y direction. So the components of vector 2v are 6, -6. And you might notice that if I take 2 times the vector v, I can literally write v in its component form and distribute the 2 into the parentheses and get vector 2v. So this is a property of vectors, which we're going to look at on this next page, some properties of vectors. Let's just take a quick look at what we just did. We took a number and multiplied it into a vector. Here we go. It's this guy right here. This is what we just did. If vector u is given by the components a sub 1, b sub 1, then c times vector u is c times a sub 1, c times b sub 1. Now, in this example here, the variable c is being used to represent a real number. And in this context here, we call c is a scalar. We call c a scalar. All right, a scalar just means some real number. It's not a vector. All right, a vector is not a real number. A vector is described by 2 components, one in the x, one in the y. It has direction, it has magnitude. All right, scalar is just some number. All right, so here we have our addition property, which we looked at, and our subtraction property, which we looked at, and now we have multiplying a vector by a scalar. So let's come back over here. Now we're going to put all those properties together, and we're going to do 2 times vector v minus u plus w. And what I want to do is I want to do this in 2 different ways. I want to do it by graphing, and then I also want to do it by algebraically finding the components of this vector. And when I say this vector, I mean that this vector, this whole thing, this thing is one vector. Okay, when we combine all those together, we're going to get one vector, and it's going to have some x component and some y component. All right, what do you want to do first? If you want to pause the video and do it either algebraically or graphically, go ahead and do that, and start it when you're done. All right, let's do graphically first. I think that might have the most impact, and I just erased my 2v, but let's put it back. Okay, so we're going to start here. We're going to go 2 v's. All right, so there's v plus v. Now we got a minus u. So u is 1, 4. So minus u is going to be -1, +4. It's going to go in the opposite direction of 1, -4. So I'm going to start here. I'm going to start where I left off, and I'm going to go -1 in the x direction and +4 in the y direction. It's going to take me right there. Okay, so let's write this down. This is the opposite of u. This is vector v. This is vector v. So far now, we started in the middle and we've got two v's minus a u. So if we drew a vector starting at 0, 0 and finishing here at wherever we're at, something -2, that would be 2v minus u. But now we want to add a w. So we're going to tack on to the end of this opposite of u, -5, 7. Let's do that in orange. All right, so starting here, I'm going to go -5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, up 7. 1, 2, 3, 4, 5, 6, 7. That's going to be right there. Negative, let's see if I can draw a straight line. Ooh, that's pretty good. I'll take it. A ruler would be good. So this is vector W. Okay, so where did we start and where did we finish? Well, we started here and we finished here. So that is the result of all that computation. Let's do purple. So this vector, that's hard to see, this vector right here is 2v minus u plus w, and we could certainly get the components by looking at the graph. We have 0 movement in the x direction, and it looks like we're going up 5 in the y direction. So that should be the components of our vector. Let's do it out. Let's do algebraically 2 times v minus u plus w and see if it works. So 2 times v minus u plus w. So we'll do the distributing first. Okay, now for the result of this, the x component is going to be found by using these x values. So we're going to go 6 minus 1 plus -5. That's going to be the x component of the result. And then the y component of the result is going to be found using these values. So we're going to have -6 minus -4 plus 7. We'll do that higher mathematics. And hopefully we get 5. So we get 0, 5, which we can see from the graph is exactly the result we got when we solved it graphically.